Hello, welcome to Electronics Education. This is Vincent Chang. So today we're gonna continue our learning around emitter follower, small signal analysis for emitter follower. BJT emitter follower, part 2, output resistance. Output resistance. So in the previous lecture, we have analyzed the first two parameters of the emitter follower, input resistance and the voltage gain. Input resistance and the voltage gain. So what's the input resistance? Is the resistance seen at the right hand side of the RS. It's the capital B in parallel with the RIB. And RIB is the series combination of the two components, RB, R pi, plus the 1 plus beta, RE in parallel with RL. What about the voltage gain? The voltage gain is actually a product of the two voltage ratio. The first ratio, VO over VB, and then the VB divided by Vs. And these two outcomes tells us the two important characteristics of the emitter follower. Number one, very high input resistance. So number two, the voltage gain is less than 1, but very close to 1. Now, so in this lecture, we are going to focus on the third parameter, which is the output resistance, excluding RL. So looking back to the amplifier, the output resistance are out, excluding RL. So the resistance, if you look at the equivalent circuit on the right-hand side, between the pink point and the ground, looking back into the amplifier, excluding the load resistance. All right? So the first step, when you analyze the output resistance, remember the first step, set the input signal source as 0. Just set the input signal source as 0. So let's just ground the left-hand side of the RS. So look at the equivalent circuit. Okay? And then the second step, because it's excluding the load resistance, so we can simply take out the RL. So remove the RL. And then here comes the third step. You apply a voltage generator. Apply a voltage generator across the terminal, the output terminal, between the pink point and the ground. And then send in a current, the AC test current. Okay? So testing voltage and testing current. So the ratio of the VT and I, the relations between the testing voltage and the current will give you the answer, will interpret the value of the output resistance, So VT over I will give you the answer. So the key to solve the output resistance in terms of derivation, mathematics, is to find out the relationship between the testing current and testing voltage. Testing current and testing voltage. So try to dig in, to move around, try to explore the relationship, and try to, hopefully you can consolidate a resistance to describe the ratio between VT over I. And that resistance is the output resistance. So what's the relationship? Based on the Kirchhoff current law, tells us the sum of the two current equals the current going out of the pink node. Right? And then focus on the relationship between VT and I. So IB is the one that you want to replace it. You want to replace this base current, the unwanted variable. So what is the IB? IB is the opposite of the green current. It's the opposite of the green current. So what's the green current? The green current is the voltage. It's the voltage across the terminal divided by the total resistance. So what's the voltage? The voltage is actually VT, right? The voltage between pin and the ground is the same as the voltage between pin and that ground, right? So the VT divided by those two guys in parallel first, RB in parallel with RB and in series with R pi. Get it? And the IB is the negative of this green current. It's the negative of this green current. So if you substitute IB with this red highlight equation, then you see what? You see on the left-hand side is the current, testing current. And the right-hand side is the testing voltage. So now the answer comes out. The output resistance comes out. If you watch carefully about this expression, it's the inverse of what? Of the two inverse. Parallel combination. The inverse of the two inverse. The first inverse of the resistance is RE. The second inverse is a little bit complicated. So this is the output resistance for the emitter follower. So now I'm going to ask you to think about what's the meaning behind this equation? What's the meaning? In other words, can you analyze this based on inspection without going through the mathematical derivation detail? Can you write out? Can you use maybe 10 or 20 seconds to say this is the answer? Then I don't need to do I don't need to derive this. So this is the skill I want to cultivate. I want you to cultivate, and this is also the key takeaway I want you to receive from this lecture. Okay, so think about this. Take 3 or 5 minutes and come back in 3-5 minutes. Try to explain. Can you analyze the output resistance based on inspection? So let's pause for 5 minutes. Have you figured this out? The first component, this is RE, right? So someone asks you, what's the resistance between pin and the ground? You say, of course, it's RE. RE. Easy. And then, what about the second component? There's more. So the second component is the parallel of the RS and RB, and then in series with R pi. Right? S, B, and pi. S in parallel with RB and in series with R pi. Oh no! Because looking this direction, you see what? It's not a monster, but you see what? Something important. Beta IB. Current control, current source. So reminds you, the current going this way is IB. And then from the third terminal will contribute the beta IB. And then the total current is the sum of these two. 1 plus beta. So when your eyes is placed at the emitter, right? Let me say this first. If you are looking into base, the emitter guy, from the base perspective, you have to what? When you try to take the emitter back to the base. So you multiply, right? So now we just flipped the role of the emitter and the base. You just put your eye in the emitter point at the emitter's perspective. So something from base going back to emitter should be divided, right? Should be divided by the 1 plus beta. So this is also an alternative version of the resistance reflection rule. Alternative version for the resistance refraction rule. So from emitter's perspective, the base guy, the base resistance taking back to the emitter has to be divided by the 1 plus beta, right? Beautiful. So the major takeaway of this lesson, of this lecture, is you are able to use the analysis by inspection and write down this with confidence, right? You want to try again? Right. What's the upper resistance? So I'm taking out the equivalent circuit. I'm looking at the original circuit, original one. The first component is what? RE. And then what? Then S in parallel to B, because based on, if you see what's in your mind, it's hybrid model, right? So you forget the RE. So you based on the R pi. So S, B, pi, and from base back to emitter divided by 1 plus beta. This is the answer. So I hope you can become more confident and use the analysis by inspection to solve some of the major parameters of the amplifier circuit. Thanks for watching.